Hey, welcome back to Mr. P Helps with Algebra. This is Unit 2, Topic 3, Lesson number 2. So we're once again dealing with systems of equations, and we're going to start off with a warm-up about substitution. So this is a lot like yesterday's warm-up. So we're going to take what's x, plug it in for x, and what is y, and plug it in for y, and see if it equals 12. 3 times 2 is 6. 6 plus 4 times 2 is 8. 6 plus 8 is 14, so that's not a possible answer. So that's 9. 2 times 2 is 4, so that makes 13, so that's not a solution. 3 times 4 is 12, plus 0 is 12, so that is a solution. So that's 0. 2 times 6 is 12. Add those together, and yes, that is also a solution. That happens to be the x and the y intercepts, which is one way that we're going to graph in the future. Okay, so I'm going to do the same thing over here. Looks like we've got an x of 2, so that's 5 times 2 is 10, minus nothing is 10, so that's an answer. 15 minus nothing is not 10, so that's not an answer. 5 times 0 is 0, minus negative 10 is the same as plus 10, so that is an answer. And that's going to be 5 minus 1, which is 4, so that's not an answer. All right, so this lesson is called Too Big or Not Too Big. And basically this gets us to understand a little bit more about the boundary of an equation and being able to turn standard form into slope-intercept form. So we're not actually going to convert it using literal equations. We're going to convert it by figuring out, hey, well, here's a graph. Now let's find the slope-intercept form of that graph. Okay. Carlos, considering the most about, so this was a review of what we did yesterday. So was 12 cats, 12 dogs, was that a viable solution? The answer was no. And the reason why it wasn't a viable solution because it cost too much money, which brings us to startup costs. Now, I've done a little bit of this lesson already just because I know it's going to be a little bit time consuming down here at the bottom. So what we're going to do is find 5 solutions that are too big, 5 that are too small, and then 5 that are just right. So here are the 5 that I have chosen. Now, these aren't the only answers. There's actually going to be, let's see, 15, 10, 5, 0. So it looks like there's going to be 5 more possible answers that could have been exactly $1,280. So there's 10 possible choices. But I did this because I want you to see the pattern. For every 5 cats, gives you space to have 2 dogs. So hopefully you can tell that this is decreasing by 5 and these are increasing by 2. So that means 15, 10 would have been an answer, or 10, 12 would have been an answer, or 5, 14 would have been an answer, and so forth. So I pretty much gave all the answers. So let me go back to the graph. So now I'm going to make each box worth 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, and then the top is going to be 40. Same thing going the other way. So 2, 4, 6, 8, 10. Might as well keep things the same. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Pen's not writing too well here. And there's 40. So I'm going to make, I think I've been doing it opposite of this, but I guess we can stick with this. Cats is X and dogs is Y. I thought I'd been doing it the other way around. So that's going to be 40 cats, 0 dogs. 40 cats, 0 dogs would be right here. And 35, 2 would be 2, 4, 35, 2 would be right here. Okay. Pen, there we go. So then the next one's going to be 34, which will be right here. And what you should be noticing, and I'm not going to flip back and forth, is that every 5 it's going up 2, and that these are creating a straight line. Then, what you're going to notice when you do these parts, come up with non-viable solutions and viable solutions. Starter call, so which one is this? 5, that would be too big. So that would be things like 20-20 or 30-30 or 40-40. Those are all going to be too big. And those are all going to be points up here. So what you find out is that everything below the line is a possible solution. So whenever it's less than or equal to, that means you shade below the line. Because all of these answers that are possible solutions, like 1, 1 or 2, 2, I know I'm being a little bit silly about these numbers, but all of these are viable solutions, and they're all below this line. Anything below the line is an answer. Anything on the line is also an answer. Keeping in mind that it's a discrete question, so not everything on the boundary is a possible answer because it does have to be a whole number. Okay, so the same thing goes with this constraint, which happens to be space. I once again took the time and liberty to show you some of the possible answers that are exactly just right, 360 feet. Notice once again the pattern. For each dog, and once again I like to do dogs as X and cats as Y, which is opposite of the graph I just made. So you can clearly see that for each dog pen that's being added, it takes away the space of 4 cats. Well, now keep in mind that makes sense because when you look right here, it takes 4 of these to equal 1 of these. And let me take a second to go back and how did I know this was decreasing by 5 for every 2 of these? So let me go back to the numbers. Look at the numbers. 32 and 80. Now I know it's not very easy for you to understand what the GCF of those two numbers are. The LCM, the lowest common multiple. So in this case, it happens to be 160. How many times is 80 going to 160? Twice. How many times is 32 going to 160? 5 times. So for 5 of these is 160 and 2 of these is 160. That means for every 2 dogs I take away, I can include 5 more cat pens. So that's really how I came to that number. So which means that's really the slope. So 2/5 would represent the slope of that line. Or in this case, negative 2/5 because I use X and Y separately, differently. Okay, so these points, same thing. So we got a slope. You can clearly see that for every 1, it's increasing in dogs. It's making 4 more cats. So it's going to go up 1, right 4, or I'm sorry, down 1, right 4 because it's decreasing. So that's going to be the slope of the equation. Now, once again, you can do this and you can graph it, and I think I'm going to give you that paper. But you're going to clearly see that everything below the line is going to be a possible solution as well. Okay. So pretty much, I think I've hit all that points. So let's go straight to the homework. It says graphing inequalities on a coordinate plane. Graph the following inequalities on a coordinate plane and plot the points to make sure the correct region is shaded. So pretend that this is an equation, 4x plus 3. Now by now you should already know how to graph linear equations. We know that this is slope-intercept form, which means 3 represents the y-intercept. I'm making each point worth 1. And if the equation has a slope of 4, 1, 2, 3, 4, that means the next number is going to be both 4 above, 1, 2, 3, 4. But the next previous number was going to be 4 below, 1, 2, 3, 4. 1, 2, 3, 4. I think I miscounted. 2, 3, 4. Okay, so there's your boundary line. And it does say or equal to, so that means anything on that line is an answer. And the answer is going to be anything less than. So as I mentioned before, don't think of it as a left and right thing because that's going to mess you up because sometimes it's going up and sometimes it's going to go down. Always think of it in terms as top and bottom. So if I pick a point down here, that is below the line. If I pick a point over here on this side of the boundary line, all of these points over here are above the line. So everything below this equation is a possible solution. Yeah, I know I'm a little bit messy with my shading here, but I think you get the point. So anything below this boundary line, because it's less than, is a possible solution. All right, so this time it's going to be x. Pretend it was x equals 20, which I know isn't a function. And I'm going to have to change the numbers here because 20 is not going to fit. So I'm going to make it maybe, 2, 2, 4, 6, 8, 10. So that means this is 20 right here. Actually, maybe I should go by 5. So let's erase that. Let's go by 5s. That'll fit a little bit better. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. Okay, I might have miscounted, but I think you get the idea. So assuming I'm going by 5s, 5, 10, 15, 20, 25, 30, 35, 40. No, I think I did it right. Okay, so assuming that it's not going to be a function, x equals 20 would look like this, 5, 10, 15, 20. It would be if x is 20, that no matter what y is, x is always 20. So it's not a function, it's going straight up and down. So then when it says x is less than 20, that means anything less than 20 means it's pointing to the left. So x can be 10, it can be 5, it can be 0, it can be negative 5. So it all just depends on whatever it is. So I would then, once again, lightly shade everything on the left side. But like I said, yes, I know. Don't consider it left and right side. Think of it as top or bottom. The only time you're ever going to think of it as left and right is when it's not a function, which means it's going straight up and down because it's a straight up and down line because it's x equals 20, which, yeah, usually you don't see those very often because in a word problem that would not make sense that you can have multiple answers for the same thing. All right. Once again, thank you for watching. Please give it a like if it helped you learn something, and subscribe if you haven't done so already. Thanks, and have a great day.